3-1 Quadratic Functions, Day 3. Your learning goal is that you'll be able to write functions in equivalent forms and graph functions with and without technology. Now, in the book, your book is different and it has a different form for standard form, but this is the standard form we're going to use. And in this form, when you're graphing the parabola, it'll still face up if A is positive, and if A is negative, it'll face down. So that's very important to help you know the orientation of your graph. Now in this form though, we don't have the vertex readily available, and we can't use transformations. So to find the vertex, you're going to use this formula, because your vertex is a coordinate, x and y. So to find the x, you will do the opposite of b over 2a. That'll give you the x in the vertex. To get the y, you have to plug in the value of x and solve for y. So that'll give you your vertex. And then your axis of symmetry, our AOS, would always be x equals the x value from your vertex okay. Your domain is still the same. And then your range, depending upon which way it's facing. If it's facing up, it'll be the y from your vertex to infinity. Or if it's facing down, it'll be negative infinity to the y from your vertex. So you have to use your vertex values to help you get the axis of symmetry and the range. Now, the intercepts are a little different. I'll go over those when we actually graph. Example 1, we're going to graph the quadratic function using the vertex and intercepts and find all the characteristics of this function. So first, you need to identify a is 1, because it's the number in front of x squared, b is negative 2, and c is negative 15. Now, this is standard form, so we have to find the vertex. And we can't use transformation. So we're going to find the x, we're going to do the opposite of b over 2a. So the opposite of b would be positive 2 over 2 times 1. So that's 2 divided by 2, which is 1. So the x in our vertex is 1. And then what you're going to do is you're going to plug in 1 for all the x's. And that will give you 1 minus 2 minus 15. Using the order of operations, negative 1 minus 15, which gives you negative 16. So your vertex is 1 and negative 16. Now sometimes you're going to have to change your graph increments. So I would probably count by 2s. 10, 12, 14, 16. Okay, so our vertex is at 1 and negative 16. Okay, and we already know it's going to open up because A is positive, so let's just write that so we'll remember. Okay, so our axis of symmetry, which is our next characteristic, would be x equals 1, because it's always okay. Then we're going to find our x-intercepts. What you want to do is set y equal to 0, and you're going to solve for x. your solving for x consists of either factoring or the quadratic formula. So are there two factors of negative 15, which will give us negative 2? Let's see, negative 5 and 3. So we set those equal to 0 and solve for x. So I got 5 and negative 3. So my x-intercepts are 5, 0 and negative 3, 0. So 5, 0. And, oh, put it at the wrong spot. Negative 3, 0. And then to get your y-intercept, you would plug in 0 for all the x's. And you would solve for y, which in this case would be negative 15. So your y-intercept is 0, negative 15. So that'll be right there. So then you just draw your graph. And now we can do our domain, which is negative infinity to positive infinity. And our range, our lowest y value comes from the vertex, which is negative 16 included to infinity. Example 2, we're doing the same thing. Let's first rewrite this because sometimes they'll have it not in the correct form. So you want your ax squared to be first, your bx second, and your c last. Okay, so we have to find the vertex, remember. So to find the x, we're going to do the opposite of b. So a is negative 1, b is negative 4, and c is 5. Can't write it there. So we're going to do the opposite of b, which is 4 over 2 times a. So 4 over negative 2 gives us negative 2. So that's the x in our vertex. Now to find the y, you're going to plug in negative 2. So we're going to do order of operations. Negative 2 squared is 4, but there's a negative on the outside, so it makes it negative 4. Plus 8 plus 5. So that gives us 4 plus 5, which is 9. So our vertex is negative 2, 9. One, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so now let's find our axis of symmetry, which is always x equals the x in the vertex. So that's that line going straight down the middle. And now I'm going to find the x-intercept. So first you set f of x equal to 0, or the y. And you see if you can factor it. If you can't, you can always use quadratic formula. X equals negative b plus or minus square root b squared minus 4ac all over 2a. And then you just simplify it. So you're going to get 16 plus 20 over negative 2. And usually you don't want a to be negative, but So that's 4 plus or minus square root of 36 over negative 2. This comes out to be a perfect square. So we're going to get 4 plus or minus 6 over negative 2. So 4 plus 6 will be 10 over negative 2, which is negative 5. Or 4 minus 6 will be negative 2 over negative 2, which is 1. So my x-intercepts are negative 5, 0, and or 1, 0. One, two, 3, 4, 5. To get your y-intercept, remember, you set all the x's equal to 0. So basically, you'll be left with C, which is 5. So your y-intercept is 0, 5. All right. Excuse me, I made a mistake. Tisk, tisk. It's supposed to be 1, 0, not negative 1. All right, there's our graph. Domain. Where can I fit it? I'll fit it here. It's negative infinity to positive infinity. And then our range, now it's facing down, so you're going to go negative infinity to my highest point, which is the y in the vertex, which is 9. And that's your graph. Just to note, that first example, our vertex was 1, negative 16. In the second example, the vertex was negative 2, 9. When your parabola is opening up and your vertex is now considered a minimum because it's the lowest, and when they ask you where determine or find the value and determine where it occurs, you'll say the minimum value is negative 16 and it occurs at x equals 1. So that's what they mean by that. And then of course if it opens down, this is your maximum. And you can tell this, if a is greater than 0, it'll open up. And if a is less than 0, it'll open down. So that's a maximum. So you'll say it has a maximum value, or the maximum value is 9, and it occurs at x equals negative 2. So just in case they ask you that, you'll know how to answer.